All right, so this section is 6.3 and it is applications of linear equations. So, what we're really going to be looking at for this section is going from a word problem or words to that math equation or that math expression. Remember, an equation has an equal sign, an expression is just different letters and numbers combined. So, for example, this right here is an expression, right? X plus 7. There's no equal sign. Even saying like 2 plus 4, that's an expression or fractions or anything. Okay, so let's look at this. Our objectives is to use equations, and we also have percents in our equations as well to solve problems and to solve a formula for a variable. So we're kind of working with everything we've been doing, but with more variables and words to variables. So I did this little chart in your notes for you just to kind of help with some of the phrases. Um, Basically, like if we look at this addition section, the word sum should mean add, right? Or we can say increased by, added to, more than. All those words increased by, added to are all in here for you. Subtraction, we could just say subtraction. We can say minus. We could say difference, less than, fewer, right? So any of those words where you need to go down um, means subtraction. Multiplication, we can use times, product. Of a lot is multiplication. So, um, and then yeah, we could use multiplied by, obviously. Twice a number means 2 times a number. Triple a number means 3 times a number. That's also multiplication. Division, we usually use divided by, or we can use quotient. Reciprocal is, um, like reciprocals where you flip it over and multiply, right? Which is division. So reciprocal. Okay. This bottom part you can look through. I would cover this up and just think of whether or not you can figure this out and get to this. Okay. So big one, let's look at just second one real quick. Twice the sum of a number and 7. Look at how that's written. Twice the the sum of a number and 7. So the 2 has to be outside because it's times by both the number and the sum of the number and 7, right? This whole part, it's twice of that whole part. Okay, so be careful where you need to put a parenthesis. Okay, but I think if you covered that up and went through those on your own, it'd be a really good practice. But let's do a couple together. Problem 1 here says, when 5 times a number is decreased by 8, the result is 7. So it has the result part, so it's going to be like an equation. So 5 times a number. First of all, let's let a letter be the number. So we like to use N or X. I don't really care either one. So we'll let N equal the number. And again, you could use X's. Doesn't matter to me. And what do I, when I say 5 times a number, so a number is always going to be your variable. And when I say 5 times it, I would write it like that, 5 times n. So our first idea piece is 5 times n. I can write that as 5 dot n, right? Or a little x. We don't like using x's as our times. It just looks like an x. So you can use a dot or put them next to each other like I did, which means times as well. So we now have 5 times a number. Now it is decreased by 8. So what I have right now, 5n, is decreased by 8. So then the minus 8 goes after it because you're decreasing it by 8. Can't mess up the way you do your minus or your division or it'll be wrong. Okay, the last is the result is 7. So the result is 7. Okay, then we can solve this and get what is the number piece, okay? So this is the main idea for today. Can you figure that part out? Solving it is something we've already learned. So it's just reiterating that, solving an equation. So if I add 8 to both sides, then I would have 5n equals 15. 8 plus 7, divide by 5, and n equals 3. Okay, so our number is 3. So when 5 times a number is decreased by 8, the result is 7. That number has to be 3. Okay, a number is decreased by 30% of itself. The result is 91. Okay, so a number is decreased by 30% of itself. First of all, when I want to work with a percent, 30%, I have to use the decimal. So what is the decimal of 30%? Move the decimal 2 places, right, to the left. So 30% as a decimal is going to equal 0.3, right? You can write as 0.30 or just 0.3. So move the decimal 2 places. Now that's a number we can work with, okay? And then we still have n is equal to a number. I'll just keep using n because n, a number, like it kind of goes together for me. Okay, so now we can look at our problem again. A number is decreased by 30% of itself. So a number is n. It is decreased by, which means minus, right? So it's decreased by, how do I write 30% of itself? To figure out any percent, you do the decimal times that number. So to get 30% of itself, and I like the word of to think of multiplication. It almost always is that way. So it's like 0.3 times n because it's itself. Okay, so 30% of n, the result is 91. So it equals 91. Okay, do I need the dot between the 30% and the n? No, it could just be 0.3n. That's totally okay. Now to solve this, why am I always yawning when I go to make your videos for this class? All of your videos, I'm going to have my eyes watering and be yawning. Sorry. Be like, gosh, my teacher gets so bored, she starts yawning. Okay, so when I have 1n and I minus 0.3, I want you to think of this as a 1n. So be careful of that. 1 minus 0.3 is 0.7 n equals 91. So just remember that when you just have an n, it's a 1n. Okay, then I can divide and find what n equals. Gosh, I might have to grab my calculator for that one. I don't know what 91 divided by 0.7 divided by 0.7, 130. Okay, so 130. For your homework, you're going to set your equation up on a lot of them, so you'll have to type that piece in and then solve it as well. Okay, so number 3 says 2% of what number is 55? So let's write that 2%, right? So 2% is the same as 0.02 because I've moved the decimal 2 places to the left, okay? And then of what number, we'll just use n still for what number. And 2% of what number is 55? So 2% of what number would be times, right, is equal to 55. I'm just going to kind of go like that so that we don't. Goodness, I did not give myself enough space. It's because the Apple Pen, when you write, is fatter, so I run out of room. Okay, so then I see 0.02 times n, so I'm going to divide 55 by 0.02, and I get a big old number of 2,750. So 2% of 2,750 is 55. You know, 2% is pretty small percent, so it's going to have to be a big number. And you could double check by taking your big number, 2,750, times it by 0.02. Do you get back to 55? Yes. You can always check your work a little bit. Okay, 10 is 28% of what number? So how do I write 28% as 0.28, right? Two places over. So 10 is 28%. So when I look at this one, um, it's kind of written like backward the way we think of it, would be 10 is kind of, right? 28% of what number? So 10 equals 28% of what number? And then from there, we can divide and solve. So that one, um, we got to divide backward. So 10 divided by 0.28, because you got to divide. This one doesn't go in evenly, but that's okay. Divided by 0.28, divided by 0.28 this way, right? Because you're going to solve for the n. And I get 35. That is not a 3. We'll just round to 2 places. So 35.71 equals n. If you wanted to keep the fraction, you could, which would be 250 over 7. Okay, if you need exact. So you could keep the fraction if you wanted, because 10 over 0.28, um, you'd have to move the decimal 2 places, add 2 zeros to the top, so you get 1,000 over 28, and then reduce. So that's where I got the 250 over 7. Oh, I just plugged it into my calculator. Totally cheated. But you could get it that way. Okay, number 5. 5 is what percent of 120? So 5 is what percent? This time I'm looking for the percent. So 5 is, right, is kind of means equals what percent? I don't know what that percent is. So let's call it X. X will equal the percent, right? And of 120. So this is what we're looking at here is that percent times 120 is going to give me 5. All right, so we're dividing and we better get a decimal. I mean, we can have over 100%, but it's not common. Only when people don't really know math do they tell you, you need to give 110%. Well, I only have 100%, so, right? So divide 5 by 120. So 5 divided by 120 is going to give us about 0.042. If I just stop there, 0.042 is equal to X, because we're going to divide by the 120. I could show that. There we go. And it's a decimal. We could get the fraction again. The fraction is 1 over 24. Oops. 1 over 24 is equal to X. So either way, but we like the decimal because we want the percent. Well, we have the decimal or the fraction. In order to get the percent, now we moved it to the left to go from percent to decimal. Now we're going decimal to percent, so we move it to the right 2, and that would give us 4.2%. Okay, so you had to go back because it wanted the percent for that one. All right, number 6, the difference between 3 times a number and 2 more than 2 times the number. Okay, so the difference between 3 times a number and 2 more than 2 times the number. Wow. Okay, the difference between 3 times a number and 2. Let's just start with that. The difference between 3 times a number. How do I write 3 times a number? 3n. So we'll start there. 3n. Okay, and that's 3 times the number. And we want the difference between this and all of this. So we're going to write difference between those, right? Minus. And then the other thing is 2 more than 2 times the number. When I start to see more than one thing on a minus, I am going to think I want a parenthesis around that second piece. That's the hardest part of this. And that second part says 2 more than 2 times the number. So 2 more than 2 times the number. So 2 more than 2 times the number. So 2 times the number, and you want 2 more than that. When you say 2, you could have now because it's plus, you could write it either way, but you're wanting 2 more than 2 times the number. So you're gonna add 2 to that 2 times the number. Okay, remembering that parenthesis will be the hardest part because if I don't use the parenthesis, I'm subtracting that whole thing off. I will not distribute this negative correctly, and you'll get the problem wrong. Okay, we can't solve this, but we could simplify it a little by distributing that negative. So then we would have 3n minus 2n minus 2, distribute that negative to the 2n and the 2. And then I could combine 3n minus 2n as 1n, or just n minus 2 is the final simplified. Not all of these do you have to simplify. A lot of them, it's just write the equation. No, they may make you, no, I don't remember. They may make you simplify more than I realize. Okay, so that was one of the harder ones. Again, the top has more for you to practice too, or you can just cover and practice those. Or goodness, I guess you practice in the homework too. And you could always click similar question, even if you get it right, and try a problem until you really understand it. Okay, problem 7, solve this for L. So we have, this is a real formula. It's perimeter, 2L plus 2W of a rectangle. And you want to solve for L. So when we're doing formulas and solving for formulas, you're still doing those opposite operations, but with letters. So when I look at this, I see the L right here. It has something added, and we always want to get rid of what's added or subtracted to the letter we're looking for first. So whatever helps you remember, this is what I'm solving for, okay? So I'm going to minus the 2W from both sides. And think about how I should write that on the left. The P is there first, and you are minusing 2W from that side. So when I write it, it better be P minus 2W equals, these go to 0, the 2L. I'm going to write it a little bit capital so it doesn't look like a 21. Okay, so then from here, I have now added or subtracted away things. Now I see 2L, I see times. So I'm going to get rid of this by dividing by the 2. 2 ways we can do this. We can split this 2 up under every single term. Why? Because the 2 can cancel under the W, but it can't with the P. Okay, so then I have P divided by 2, oops, minus W equals L. This is the most simplified method. If you would have just written right here, I'm going to erase this because I don't want this to be the way you do it. If you do it this way, it's not wrong. And it's fine in science and stuff like that too, but it's not simplified all the way. You would then have to take this 2 and write it under both terms like I did here and simplify. So this is not my favorite way. To write it under all of it. So I like to break it up. All right, so that is how you solve for this one formula. I think I have a couple more, right? Gosh, I don't have. Let's scroll down and do a 7B. I guess that would be just sneak it on somewhere on your paper. I'm going to call this problem 7B. What if you have something like the area equals length times width times height? You don't have to have the dots, and you want to solve for L. We'll just keep with solve for L because we like L today. How would you do it if everything is times? Everyone gets really stopped up on these type. Ooh, I want to even, no, it's fine. It's okay. If you have times, we're going to divide by both the W and the H that we don't want at the same time. Then these would cancel, and I have A divided by WH equals L. So you can divide by like more than one thing at the same time. Okay, just bringing that up because I get that question a lot, and it's actually way easier than some of the other ones. All right, number 8, the total price of an article purchased on a monthly deferred payment plan is described by the following formula. T equals D plus PM. T is the total price, D is the down payment, P is the monthly payment, and M is the number of months one pays. Solve for P. That's a lot of words for solve for P. Okay, so let's write this down here. So we have T equals D plus PM. So where is what we want to solve for? It's right here, right? That's P. We want to solve for P. Is there something added or subtracted to that term? A D is added. So we got to move the D first. Okay, it's a positive D. So I'm going to minus D from both sides. When I do that and I write the left, it's going to be T minus D because T was there first and you have to minus D from it. They cancel here, so it's going to equal the PM here. Almost there. Now we can divide by the M, and this time I will take either one. You can go like this. Why? Because M can't just cancel with T or D, so it doesn't matter. Could you have written it? Okay, could you have written it like that's not a P, it's a D. T over M minus D over M equals P? Sure. If my math lab counts this one or this one wrong, just send me and ask the instructor and I'll give you it. I would take either one. Okay, do you see the difference though? I can't cancel anything, so it doesn't really matter. I like it when there's numbers that you put it under each one. All right, that's all it really, that was a lot of wordiness for just solve for P. Number 9, I go to the store to buy a computer at the cost of $430. There is a sale and I save 25% and I have to pay tax. What is the cost of my new computer? So just a little bit of percent work here, right? If I go to the store and this thing costs $430 and I save 25%, how do I figure out my discount? Well, me personally, if you move the decimal one place, it's 10%. So I'd be like, okay, well, move the decimal, that's $43, and that's only 10%. Oh, I get to double that. That's $86. Oh, but I still have another 5%. Well, that's half of 43. Oh, so I save another 20-ish dollars, right? That's how I actually work in the real store. So moving the decimal one place is 10%. So you're leaving a credit card tip and you want 20%, you double that number. So I'd move the decimal over and I would see 43 and I would double that. And that's the tip I should leave. Okay, so, but we're doing 25%. How would I do it officially to get an exact answer and not just guess it with my head and say, oh, about $20 more? I would take the $430.67 and I would times it by the decimal of 25%, right? 0.25, because this is 0.25 and this is 0.06, just so we know. So I'm going to get out my calculator and I'm going to take $430.67, times it by the 25%, and I'm going to round to the nearest dollar, so or cent, and so that's 67 cents. So $107.67. So remember, I was at 86 and I had to add another 20. That's about 107. Okay, so that's what we save. So what I'll do now is take the $430.67 and I get to subtract off that money. Okay, so then I'm going to take $430.67 and I'm going to minus the 107.67 cents. Gosh, that's so pretty. So 323, I thought I wrote it down wrong because the cents canceled perfectly. So now I have the price. So I can't do a discount and tax at the same time. You have to do them all separately. So I do my discount to see what I pay taxes on. I'm only paying taxes on the $323, but you cannot say 25% plus the 6%. You can't combine those in any way. They have to be separate processes. Now I can figure out 323 dollars, right, times my 6% is going to give me my tax. And this was our discount. Okay, so 323 times 0.06 is going to give me $19.38. So do we add the tax back or do we get to subtract it? We add it because we owe it. So a discount, we save it. So we minus tax, we're going to add because darn it, we have to pay it. So we were at $323. Now I have to add $19.38. So add that to 323, and I get a new total of $342.38. And this is my solution. Okay. That's the cost of my new computer. All right. So let me know if you have any questions on this. Yeah, there you go.